Hello, welcome back again. This is it. It says lesson 5, but remember we did cosine and sine as one lesson, so we kind of put those together. This last section is just basically problems involving these 3 trig ratios. So you could be, generally speaking, you'll be dealing with 2 triangles. You have some sort of shared side that'll make them, make yourself be able to solve them using that shared side. So what I'm going to do is, we're just going to lose this for a second, and I just want you to recall the 3 trig ratios that we talked about last day, or in the last lesson, and what we used as our acronym to do that. So if you recall, we called it SOHCAHTOA. So if we picked an angle like A, we went across here, we'd have the opposite side. This would be the adjacent side, and this is my hypotenuse. The sine is going to be the opposite divided by the hypotenuse. The cosine is going to be the adjacent divided by the hypotenuse, and the tangent is going to be the opposite divided by the hypotenuse. So that is SOHCAHTOA, just in general, what we're going to use to solve all of these problems. I'm just going to jump down here. So we can use trigonometry to solve problems that can be modeled using right triangles. So we have to have a right angle somewhere in here to use trig. So when more than one right angle is involved, we have to decide which triangle to start with. So like I said, nearly all of these questions are going to involve 2 triangles, and they'll almost always have a shared side. And that shared side is kind of the key to these problems because it's going to connect one triangle to the next. So you need to identify where your 2 triangles are, first of all, where your shared side is, and then see if finding that shared side will allow you to use information from one triangle and kind of use the shared side to look at the next triangle. So the first example we have here, calculate the length of xy to the nearest tenth of a centimeter. So xy is over here. And you'll see that I have one angle here, 22 degrees, but I don't have any more information for this triangle, just 22 degrees. So I only have one piece of information. But over here, I have another triangle where I have an angle and a side length. So I can use those 2 pieces of information to find everything missing. The shared side is this YW here down the middle. And if I can find the length of that shared side, then I can use that with the 22 degrees to find the length of the side YX. So what I'm going to do is I'm going to ignore all of this over here, and I'm just going to deal with the red triangle to begin with. If I can find the shared side, I can go from there. So we need to find the length. In this case, it's YW, and that is our shared side, which is kind of the key to the question. Okay, so I have this angle here. I'm going to measure all of my sides from this angle. If I go to here, this becomes the opposite side, the side I'm trying to find. This is the longest side in that red triangle. This is the hypotenuse. So if I have opposite and I know the hypotenuse, I think SOHCAHTOA, I'm going to take the sine. So the sine of angle Z is the opposite side divided by the hypotenuse. So the length of the opposite divided by the length of the hypotenuse. All right, so this side, or the angle Z, is 20 degrees. The length of the opposite, I don't know what it is. I can call it YW, I guess. And the hypotenuse is 8.4. So I'm going to multiply both sides by 8.4, so it cancels there. And I'm going to get YW is equal to 8.4 times the sine of 20 degrees. Plug her into my calculator. 8.4 sine 20. I'm not using the inverse sine because I have the angle already. If I didn't have the angle, then I'd use the inverse sine. So head equals, I get 2.87. And I'm going to use a few decimal places, so I'm going to write it as 2.87296. Because I'm going to have to use this, my shared side, in the second problem, I want to carry as many decimal places as I can. Now, I'm going to keep, or try to keep, all those digits in my calculator and go from there. But if I somehow get them erased or something, at least I have it written down there. All right, so that's the shared side. Now, I'm going to erase all this and re-look at the question in terms of this smaller green triangle. It's going to be a 90-degree angle here. I have an angle up in the top, angle Y. I have the shared side now. YW is 2.87. And remember, I'm trying to find the length from Y to X. I can call it X, I can call it YX if I want. Maybe X would not be a good one. We'll call it YX. So if I am dealing with this 2.87, which would be the adjacent side, and then this would be the hypotenuse over here because it's across from my 90-degree angle. So adjacent and hypotenuse is going to be the cosine of y, or 22 degrees, is the adjacent divided by the hypotenuse. Or the cosine 22 is equal to the adjacent, which is 2.87 divided by the hypotenuse, we'll call yx. You give it a single variable name if you wanted, doesn't matter. Now I have yx on the bottom, I want to get it to the top. So I'm going to multiply both sides by yx. It's going to cancel over here. I get yx times the cosine of 22 degrees is equal to 2.87. Then I'm going to divide both sides by the cosine 22 degrees. And I end up with yx is 2.87 divided by the cosine of 22 degrees. And we can calculate that. And again, I can just plug it into my calculator. 2.87 divided by the cosine 22 gives me 3.09 or 3.1. So that was what the question had originally asked for, that yx. So I had to find the shared side to get it. So that's kind of, all these problems are identical, just the lengths and numbers changed. It's always going to be two triangles, it's always going to be a shared side. You're going to have to find out information on the shared side to move into the next triangle. So let's see what it looks like in this next example. Really, this is the exact same problem what we just did, except everything's just been rotated about 90 degrees. So surveyor stands on the window of the 9th floor of an office tower. A clinometer is a tool used to measure angles. So you can stand somewhere and look at something and it tells you the angle. So a clinometer measures the angle of elevation and depression. Angle of elevation is if you have a horizontal surface, you go up, that's the angle of elevation. If you go down from a horizontal surface, that's the angle of depression. So angle of elevation is the top one, the angle of depression is the bottom one, just so we're clear. The surveyor sketches the plan, measures, determine the height of the taller building to the nearest 1/10 of a meter. So we're trying to find the height of the taller building. Okay, we've been given a picture here. You can see we have two triangles. I'm going to have another right angle here. Here's my one triangle on the top. I have another triangle on the bottom. And I'm trying to find the distance from the top to the bottom of this building. How tall is it? You can see the dotted line. Maybe I'll draw it in red here. This is my shared side. So both of these triangles share the red side. If I could figure out this piece here and then this piece here and add them together, then I could figure out how tall that building was. So let's maybe call it A and B. So we'll call this top piece A, we'll call this B, and then we'll go from there. Now, if I look at the diagram, it says that the man using the inclinometer is 39 meters above the ground. So I know what B is already, it's 39 meters. I have an angle for this triangle. I'm going to find the shared side, maybe call it X. And then from X, I can find A using the top triangle. So if I use this, it's my opposite. X is the adjacent. Opposite and the adjacent is going to be TOA, or the tangent of my angle 42 degrees is going to be the opposite divided by the adjacent. Opposite in this case is 39. The adjacent is what I'm trying to find. I called it X. I've done this a few times now, multiply both sides by X. If you've seen there's a bit of a pattern, you can also think of it in terms of cross multiplying or whatever you want. If you're really perceptive, you'd see that what I'm doing essentially is just going the length, and then I'm moving that 42. So the X and the 42 tangent switch places. It just kind of works out that way if you do the two steps. So once you do this 100 times, over and over and over again, you'll see that those things just switch places. If you want to do it the long way, you can multiply both sides by X, and then you're going to divide both sides by the tangent of 42, and you'll end up at the same spot eventually, just 2 steps later. So 39 divided by tangent of 42. 10, I have the angle 42 degrees. I end up with 43.3 meters. So it turns out the two buildings are 43.3 meters apart. All right, so that gives me the first thing. The second thing is I need to use that fact that I know X, or my shared side, to find A. So I'm going to go back and relabel all of my diagrams here. I know that this X, I just calculated that to be 43.3. So if I take this blue triangle now, I have the angle here. So A is the opposite side. This X happens to be the adjacent. I have the hypotenuse here, but I don't need it. So if I am dealing with the opposite and the adjacent, I need to figure out which function that is. So it turns out that it's tangent again. So the tangent of 31 degrees is the opposite A divided by the adjacent X, which I just calculated. So the opposite, the adjacent, is 43.3. Multiply both sides by 43.3. And cancels. I end up with 43.3 times the tangent of 31 degrees is equal to A. So what I'm going to do in my calculator is take this answer and I'm going to multiply it by the tangent of 31 degrees. So I didn't have to write down any decimal places. My calculator is remembering them all for me. I end up with 26.0 meters. Now, you're like, yeah, I'm done, but you're not. So the question asks how tall the taller building is. And it turns out that you're 39 meters above the ground. You just found out that taller building is an additional 26 meters. So the height of the building is going to be 26 meters plus 39 meters, which is going to give us 65 meters. As for the nearest tenth, I guess it's 65.0 meters. So the question was a little bit tricky in how it was asking you to find that height. You needed to take the height of the smaller building, add it to the additional height that you found. All right, this one's looking a little bit different. We have sort of a three-dimensional feel to this one. We have a communications tower. We know how tall it is, 35 meters. We know a point due north of the tower. The angle is measured to be 70. Due east of the tower, the angle is measured to be 50. How far apart are the students to the nearest meter? This is a bit of a tricky type question. So what we need to do is kind of figure out what we're trying to find. It turns out that we're trying to find how far these students are away from one another. And the trick in the question here says one's due east and one's due north. So what we can do with that information is say, okay, if this is due east and due north, this triangle in red along the bottom here, that has a 90-degree angle because we're using compass bearings. But we don't know any information. We don't have any lengths down here. I don't know how long this side is. I don't know how long this side is. This gets back to the idea of a shared triangle. So the only thing that these things share is 35 meters. So we're definitely going to have to use that. Now, if I could find out how long this side is down here and then find out this one, then I could calculate this one. I can't do anything to figure out angles, unfortunately, because the 70 is going up into the air, whereas the angle down here on the bottom is talking about on the ground. So what I'm going to do is use the fact that I have this 35. I can use this blue triangle here. It's a 90-degree angle down here. I can use the blue triangle to figure out the length of this bottom piece. Maybe we'll call it X. And then I can use the green triangle here to figure out this bottom piece, and we'll call it Y. And from those two, I can figure out the distance those two are apart. So let's maybe start with the blue triangle first. If I go up here, this is my opposite, and then this X is my adjacent. So I'm going to use the tangent of 50 degrees is the opposite, 35 meters, divided by the adjacent. We'll just call it X. And then I'm going to set up the green one at the same time, because it's going to be the same question. The tangent of 70 degrees is the opposite, which is 35, divided by the adjacent, which I'm calling Y. I'm going to rearrange these things. I get 35 divided by a tangent of 50 degrees, and I'll end up with y equal to 35 divided by the tangent of 70 degrees. It's going to give me x and y. All right, so let's figure out x. 35 divided by tan 50. Just plug it in. 35 divided by 10, 50. I end up with 29.36. And then my y is the same thing, 35 divided by 10, 70. Tangent of my angle, 70 degrees. And I end up with 12.738 or 12.74. All right, so I know those two things now. I can draw this red triangle that I've kind of inscribed here. I'm going to kind of pull it out so I can see what's going on, make it look like a right angle triangle. All right, so I know that this is 12.74. I know this side over here is 29.36. Clearly my diagram is not drawn to scale, but that's not going to affect it too much. I have a right angle triangle. There's a leaf down here, this is tanus up here. I need to know this side. So I'm going to just use the Pythagorean theorem. So we'll go LT, that's the longest side, squared equals 29.36 squared plus 12.74 squared And I calculate that out. I get LT is equal to the square root of 10, plug it into my calculator, 1024.789, should be good for decimal places. And the distance from leaf to Tanis is 32 meters approximately. So there you go. That's how far they were apart. Same idea. Find the shared side, go from there. A couple more questions here. I have a box, and I'm asked to find the length of the diagonal in the box. So the reason this one's kind of tricky is because we're dealing with kind of two dimensions again, similar to the question above. What I'm trying to find is this diagonal, which is already in red on my screen, so I need to know this side, and then if I go from H across this box to F, this is a 90-degree angle there, kind of cutting right through the middle of that box. So that's what I'm looking to find. I know that this is 3 centimeters over here. I don't know what the diagonal across the bottom is, but I can figure it out using some things here. I know that this side down here is 2 centimeters. This I know is 4, and turns out I have another right angle there. So I'm going to deal with a blue triangle. I'm going to go the distance from HF, which is this corner here to this corner. So HF squared, Pythagorean theorem, is 2 squared plus 4 squared. So dealing with that blue triangle. 2 times 2 is 4. 4 times 4 is 16. So I'm going to have HF squared is equal to 20. HF is equal to the square root of 20, which is going to give me, well, I'm just going to leave it as the square root of 20. And I'll show you why that is in a second. All right, so HF is kind of the shared side. Now I'm going to deal with the red triangle. Again, I don't have any angles, so I don't really know what to do with them, but it's just all Pythagorean theorem at this point. So what I'm going to do is now I'm going to take AF, which is the distance from this corner up here to down here, which is what I'm trying to find, is equal to 3 squared plus that diagonal I just found was the square root of 20 squared. So the reason I left it as the square root of 20 because now I'm just going to square it and it's just going to be 20. So I haven't even done trig yet. I get AF squared is 9 plus 20. AF is the square root of 29. I could figure it out as a decimal, and I will. I end up with 5.4 centimeters. So there you go. That's the distance from A to F. Nothing too earth-shattering there. Pythagorean theorem question, just 2 steps, 2 triangles, one in blue, one in red. So I guess the tricky part now comes when we're asked what is the measure of angle AFH. So when I'm given an angle like this, AFH, I start at A, and then I go to F, and then I end at H. So A is here. Let me pick green. A. There's A to F to H. So I want to know this angle down in the bottom here. So I figured out enough information to do that. If I go over here, this is the opposite side. The shared side I already found is the adjacent. So I'm going to deal with the opposite and the adjacent. So I'm going to take the tangent of the angle. I don't know what the angle is. I guess I can call it AFH if you want. Is the opposite side divided by the adjacent side. The opposite side in this case is given in the question as 3 centimeters. The adjacent I found to be the square root of 20. I never actually calculated it, and I'll just leave it like that. Doesn't really matter. And if I'm trying to find the angle AFH, I'm going to take the inverse tangent of 3 over the square root of 20. Anytime I'm trying to find the angle, I'm taking the inverse. Now, I'm going to try to plug this all in my calculator at once, see if it works. So second function tangent, inverse tangent. I'm going to go bracket 3 divided by, I swear it might get a bit tricky, square root 20. Close the bracket, hit equals, and I get 33.8. We'll just call it 34 degrees. Now, does that make sense? I suppose it does. It's less than 90, which I knew it had to be. 30 degrees, it's looking pretty close to 30 if I were to just take a shot at the dark and guess. And essentially that's it. So that is solving problems with trig. If you can remember SOHCAHTOA, and you remember that you're always going to have 2 triangles or more and a shared side, and the shared side's what's going to allow you to go from one triangle to the next. Basically, you can master these problems. They're always the same. They're going to give you 2 pieces of information from one triangle and 1 piece in the next triangle. You find the shared side, you're good to go. So it's really, it might be overwhelming at first, but just knowing that they're always identical. If you're pretty good with SOHCAHTOA, figuring out the sides, you should have no issues. So that's it for Unit 8. Just remember, we'll have lots of time in class to go through any problems you may have with this stuff. So I'll leave you guys there. Thanks. Have a good one.